Hello there. Let's try to do problem 8 now while I am at it. So we need the Bernoulli number for, or we need lambda here. K equal, lambda is half below this, so lambda is 2. And that means we need here be 4 divided by 4. And I have found Handbook of Mathematical Functions, which holds the Bernoulli numbers. It's actually difficult to see where the line goes. 4, that's minus 1/30th. So that's 1/120th. All right. Of course, Mabel could compute this as well, but now I just found the right section in the Handbook of Mathematical Functions, and they had a table of them as well. Now, that immediately gives the factor to theta to 5th. Two to 5th. No, that's now what is that? Yeah, when we multiply it, we get them 10 times. Q, there we go, plus etc. Oh, it's theta f, of course, just theta f. All right, so we have h phi halves equals capital theta to the 5th minus something theta f, and the first the coefficient to q is here, it's 1 divided by 120, and on the other side it's 1/12, 10 divided, you can't see when I point that, 10 divided by 120, and then the next one gives gamma. We should do plus to make more sense, and then this one just gives gamma, and that means gamma is 1/120th minus 1/12th, which is 10 minus 1 divided by, no, 1, minus 10 minus 1 divided by 120, minus 9 divided by 120. That gives 3 minus 3 divided by 40. So I am a little off. So we must check. This should be correct because it immediately gives the right coefficient here. And the number of divisors, or the sum of the divisors of 1 is unity, of course. And when we multiply with q, that gives q plus 2q squared, etc. Of course, C2 is vanishes. So maybe we could use that, computing the next coefficient. I don't want to do that. It's not very difficult, but this is the simple way which should work. How did I get 12? Oh, that's 10q. Yeah, I don't see the error here. I won't show it to you, but I'll try to do the second term just for the fun of it, because we know C2 vanishes, and then I will use that as a mental crutch to find out where I'm wrong here. It's still Saturday evening, December 27th. I just wanted to show what I found. This is not C0. That was a mistake. Or C1, of course, it was C0. Actually, C1 is L chi of -1, and that means it's theta of -1, which we can write as 1 minus 2, meaning it's minus B2 divided by 2. And B2, that's plus 1/2, or is it minus 1/2? Well, let's check my Maple script that I made. So I define f and theta, and then theta to the 5th, and theta f up to 6th order. So n is the how far we will go. Next, I compute the one in the book, and we get 120th as C0, and minus 1/12th. Oh yeah, B2, that B1 is a half. B2 is 1/6, so it becomes minus 1/12th. There we are. So this should be the guy, but, and that's very strange, because in problem 6, we showed that these guys should, oh, and this coefficient should vanish. And if we use this one, that's what we are that's what we get. The coefficient to q squared and q cubed and q sixth to the sixth vanish. And this coefficient then gives 1/60th. So I can now derive this result, but it doesn't fit with what I expected when we go to higher terms. So that's where we stand here Saturday late afternoon. And that'll be all for today. Hello. Now it's Saturday afternoon. Yesterday was Friday, sorry about that. We did this one, and we should just find the correct value of the factor here. So that's minus 1/12 it should give. So it's together once gamma is 1/6. And then when it came to computing the coefficients, I made a slight mistake. I forgot that in F we only have the odd powers. And then when we redo the computation, we get the constant term, the coefficient to the first, and now we see that q squared, q cubed, q to the sixth and seventh all vanish as they should. Giving credence to this result. Then we can go to the last part. Derive. Actually, let's play a little with this relation first. So we have Cn q to nth 100, and they just called it S. The number of ways n can be written as the sum of 5 integers. And then we need to compute this. That's a square. So how do we do that really? I'll just check the form here. Proposition 7. So they write theta, I believe, as 1 plus 2 sigma q to n squared. And then F and of course positive sigma 1 n q to nth, and that means the product of set. So if we let D, so we write this product of F and the product of this and this let the coefficient be q to dth. And how can that come? It can be something from up here, n squared, plus something down here we call j, where j is odd, actually I think it's better to do it the other way, that it's j squared plus so we write d as j squared plus some n. Then we should have d down here as well. Oh, but that's not d, is it? It's just a number here. It doesn't necessarily mean the discriminant. So I shouldn't write d. Let's call it k. So we have a guy down here for some j times sigma 1 of k minus j squared. And then this should be changed to k. And here we sum over k. The smallest one is 1. Actually, it's 2. And j is numerically smaller than k. It can't be equal, then it would vanish. So let's write k here as well. And that means the coefficient, oops, this is the first one, of course. Let's just take it for itself, never mind, yeah. So that's what I'll use. And now let's do proposition 7 first. So we let d is the discriminant of a number field, so it's actually the coefficient cd, and that's the dth coefficient here. If it's odd, and it can easily be odd, but if d is odd, and in that case, of course, CD is L of chi evaluated at -1. So let's see what, oh, I forgot, I forgot all about this. So we'll just have to correct. We are far from finished. So, back to where we are. So that's the coefficient Cn, or Cd, and then it's 120th, that's a third then. So let's compare with what they write. This one, they call it S5, all right. So there are two things wrong. The first is, this is actually included, and so is this, because they take both positive and negative j. So actually this is exactly the same. Good. The final thing I would like to try is, in case, what did we call it? N here is equivalent to 2 or 3 modulo 4, then this term vanishes. So this is equal to 1/3. Now this is interesting. I'll just check that numerically. I don't know if Maple can actually compute these numbers. But I'll just check that, and then I write the result in the commentary. So that's all for problem 8. So deriving such equations from modular forms is kind of a sport, isn't it?